Thank you, Joseph. Yeah, thanks for having me. My name is Jürgen. I work for a company called Dynatrace. So we are originating from the application performance monitoring. So actually, we really resonate around those topics that Joseph just mentioned. Is it the code? Is it the node? Like we are doing originally really all these monitoring of infrastructure and applications and microservices. And now we also go into the direction of software intelligence. But today I won't talk a lot about Dynatrace. I will talk more about Keptn and Prometheus, about the Prometheus ecosystem. There are a couple of building blocks that we see when we're working with customers. And I want to talk a little bit about this in the context of an open source project called Keptn and how it was originally started by Dynatrace. Now it's more organizations that are joining in and contributing to the project. I would say the first part is more generic, and the second part of this presentation, I will talk a little bit about how we are trying to overcome those challenges that we see within the project of Keptn. I provided here some links. I can also provide the slides at the end of my presentation. I will put the link to the slides in the chat, so you can also take a look, and all these links, you can just click them, so no need to take notes. Actually, if you want, of course, you can do so. Well, let's get started. So what we saw is basically what you want in the end of your cloud native environment. On your systems, you have all these microservices. What you really want for observability, you have automated monitoring. So each time you onboard new applications to your Kubernetes clusters, you onboard new workloads, you want to have them automatically monitored. You also want to have alerts set up for critical applications in your production environments. And most often you also want to have some dashboards. So you not only rely on the alerts. So when something is alerting you, you get the notification. That's most often not enough. So you also want to have some dashboards where you can take a look at, and maybe already before it's alerting, you can see some of those things that are going out of the original or out of the good boundaries, and they are like misbehaving, if you already can indicate these kind of things. But you don't want to spend a lot of time, and not wasting time, but spending a lot of time configuring all those. So you really want to have this all automated. So it's basically the goal where we want to go. And we are trying to get there by overcoming a couple of challenges. So we will start with what are my basic Kubernetes building blocks, what are the central concepts, let's say, that I will be touching in this presentation. I will highlight a couple of challenges that we saw working with customers and other organizations that are using Keptn or contributing to Keptn. And then I will, for each of those challenges, I will also sketch a solution. And then I will basically talk a little bit about the open source project Keptn in the context of scaling Prometheus, but also about other things it can do. Parts of it, especially the first part, it's based on a blog I recently wrote, and also the link is provided here if you want to take a look at it. So let's start at our basic building blocks, and I would assume most of you, if you heard Prometheus or Kubernetes or Cloud Native before, I would assume most of you are very much familiar because it's very simplified here. But anyway, you have your application cluster, or actually clusters. So you might have more than one with all your applications on it. They expose their metrics on the endpoint. Prometheus is fetching all those metrics. And then you have your alert manager, you have your Grafana, all on top of your Prometheus cluster. And you also might have more than one Prometheus clusters who reach high availability. I won't touch this technical part of getting high availability of a Prometheus cluster. There are projects out there like Thanos, like Victoria Metrics. So if you're really interested in having like a high availability setup of your Prometheus fleet, take a look at those projects. You will find great resources out there. What I will talk more about how you can deal with all of this configuration you have to do. So this is more the core of this presentation. And by the way, if there are any questions, feel free to use the chat or Q&A feature of Zoom, or just wait at the end and then just throw the question in as you want. So in the beginning, when we are starting with Prometheus and with all the tools that kind of belong into this ecosystem, we start with writing YAML files, but not all the tools, they accept YAML. So for Grafana, it's usually you write some JSON. Of course, you can transform your JSON into YAML and vice versa. But usually you start writing all those files and then you apply it to your, let's say, production environment or to your staging environment. And we saw a couple of folks or organizations we're working with, they are really fighting with keeping the configuration they kind of have in their IDE or whatever, in their data store, in sync with their production environment. So it should be obvious, but it was not obvious to really have to know which configuration is right now applied in my production environment. So one very promising approach, and I think it's a very good approach, is to use a GitOps approach, where you basically put all the not only the code but also all your configuration resources in a Git repository and have some kind of operator synchronize the state of the Git repository with the state of your Kubernetes cluster. So it's basically checking if the configuration of your Git repository reflects the configuration of your Kubernetes cluster or your Prometheus installation, your alert manager, your Grafana installation, and then it will apply the changes. So there is no need of a manual edit in your production system anymore. Everything will be version controlled in your Git repository. You can manage everything via pull requests. So you really have a central, let's say, control mechanism that you can apply. And you can put all the configuration files in it. And it should kind of solve one of those problems. Anyway, you still have to write all the configuration files. And as I said, most of it is in YAML, a couple of it is might be JSON or any other language. And it's not only one file, it's actually a lot of files. So you will come up with a lot of alerting rules, a lot of different scrape jobs, dashboard configuration for all these different kinds of dashboards. You would not do, maybe you do some manual edits of a dashboard, but then to automate it, you will have some configuration files. Writing those takes a lot of time, is also some quite error prone. So what you can come up with, and I think it's kind of a natural solution, to use some kind of code generator. So basically you feed the code generator with the data, with your, let's say, with the important data points or the important aspects of what you want to achieve. And then you generate the configuration and you put this configuration then in the Git repository. So in this case, you can make use of, it's basically a reuse mechanism, and it will also help with reducing the errors of your configuration files. And there are a lot of potential code generators. I just know a bunch of them. So I put them in the reference section at the end of the slide deck. And if you know some more code generators that you are using, I would be happy if you leave a comment on the slide deck or a comment in the chat or somewhere and point out what you're using, because I think everyone should, like, maybe we can gain more insights from each other to really know what you're using. And there are a couple of generators out there, which is great. You can generate your configuration. But still, since those configurations are of different kind and you won't apply the same configuration to all of those tools, they might drift out of sync, let's say. So it might be that a recording rule or a scrape job or a alerting rule might contain different information than the dashboarding configuration. So you might apply some, or you might feed the code trainer with different data than you will do with between like a dashboard and the alerting. So you really have to take care that all of this is based on the same concepts. And this is where we think basing these, let's say, files and these very crucial parts of in the Prometheus ecosystem, base this on SRE concepts, site reliability engineering concepts. There is a great book out there I think from Google. They also publish it online for free, so you can take a look, and they really base everything on service level indicators, service level objectives, service level agreements. They have error budgets, these kind of things, where you really define what you want to achieve, what is like the important metrics, what are the important pillars of your when it comes to reliability of your system. And then you can feed this into the code generators. You can generate the configuration, you put it in the Git repository, and you apply it to your actual tools. So it's really defining what you want instead of defining how it is done. So you don't have to learn all these different kinds of languages or variants of languages, but you just define what you want to have. But of course, you might need some tooling that will translate this concept into an actual configuration that you can give to Prometheus or to Grafana. So with this, I want to introduce this open source project. I've been working with a bigger team, of course, and how we think you can automate the configuration of Prometheus, Grafana, but also other tools. How you can use this also for automating the quality gates for continuous delivery, and also to automate parts of your operations. And I didn't know about the slide that Joseph was presenting in the beginning, but I think it really resonates because you really want to know, are you allowed to put something into production? Does it satisfy a given set of quality criteria? If not, you have to hold it back, so it should not reach production. This is what we define as a quality gate. And if something goes wrong in production, you want to automatically react on this misbehaving version of some microservice, for example. So it really, I think it really fits in this context. So let me quickly explain Keptn in one sentence. I know it's a couple of buzzwords, let's say, to be honest. But let me try to break it down into smaller pieces. So in one sentence, Keptn is an event-based control plane for continuous delivery and automated operations. I think one of the most important parts here is event-based. So it's not an operator living in your Kubernetes cluster, but it's basically an event-based control plane. So it means Keptn will receive events, will act upon these events, and will send out other events. And those events are cloud events. So that's also a CNCF project. I think cloud events are already incubating. I think so. Keptn, by the way, is a sandbox project. So it's quite new, but already in the sandbox stage. So it's event-based, receiving events and sending out other events. This gives us one very important advantage. It's very easy to integrate with other tools because you just only have to send an event to Keptn, or you have to digest or just consume an event from Keptn. It's a control plane in the sense that Keptn can really connect to other tools and kind of trigger other tools when it's the right time for them to execute. Like a testing service should be probably executed after you deploy the new version of a microservice, but before you are validating this new version of a microservice. So this kind of workflow is baked into Keptn, and Keptn then will reach out to the different tools. In this sense, it's a control plane. For continuous delivery, because we can do continuous delivery, progressive delivery with Keptn, blue-green deployments, for example, out of the box, that's possible with Keptn, and automated operations in the sense that Keptn can react on any alerts from the alert manager or problem tickets from Dynatrace or whatever tool you're integrating with Keptn. And then Keptn can trigger a remediation workflow, like executing let's say a playbook in Ansible Tower or a workflow in ServiceNow, or just some baked-in remediation actions of Keptn itself. So in this sense, it can automate parts of your operations. So kind of a, let's say, compressed sentence, but it's kind of has all the information in it we need to define what Keptn really is. We have a little bit more complicated picture here. I don't want to go into detail. I just want to show you a little bit about the conceptual architecture. What are the services? We call them services, but what are basically other tools that Keptn usually integrates with? So we have our GitOps approach. Keptn will store everything in its own Git repository, but we can also link it to GitHub, Bitbucket, GitLab, whatever other Git-based repository. Keptn will integrate with your container registry like Docker Hub. Keptn can integrate with your continuous delivery if you don't want to use the continuous delivery functions of Keptn itself, where we are applying Helm charts. You can also integrate with your Jenkins installation, your XL release. And it can integrate with a lot of other tools, but I think for today we are actually focusing on the last part here, where we're integrating with tools that are providing data for observability, like Prometheus or like Dynatrace, and tools that are visualizing this data, like Grafana. So in this sense, Keptn can control the setup of Prometheus and Grafana in your installation. And Keptn lives in your Kubernetes cluster. We just sketched here that if you want to deploy something, it's basically one environment definition file that you will add to Keptn, and you will create a project in Keptn with a shipyard file. You might have already guessed that Keptn is basically the phonetic version of the captain of a ship. So the shipyard file really defines kind of the ship. And you will define if you want the blue-green deployment, if you want if you want performance tests or functional tests, if you want automated remediation strategies, these kind of things you define in the shipyard file, but you won't define how it is done. You just define what you want to have. And Keptn, for example, will set up all these different namespaces in the Kubernetes cluster and configure them for blue-green deployments. Here we're using Istio behind the scenes to distinguish between these versions and route the traffic in the right direction. So this is what Keptn can do in your Kubernetes cluster. And as said, Keptn is using those SRE concepts for configuring basically these configuration files that then will be generated by Keptn and applied to the different tools. First part is the service level indicators, or basically I just want to explain the first two parts here. The service level indicator is basically a metric. Let's just say it's a metric. That's one easy description of it. And one example would be the error rate of login requests. And the objective upon those service level indicator would say this error rate has to be less than 2%. And usually we also define some time frame. So it would be the login error rate should be less than, or has to be less than 2% within the last 30 minutes or 50 days, or just within the last time frame of the test that we just applied. So this is how we are distinguishing the service level indicators and the objective. It's important to have this distinction because you can reuse very easily reuse the service level indicators. And as an example, I have one on the next slide. Actually, what I just want to mention here is red metrics. It's for, I think, response time, error rate, and throughput, or actually it's the rate is also already the throughput, error rate, and duration, which is basically comes to a response time. These metrics, they are automatically, they're already included in Keptn. So Keptn will create these metrics for you for each microservice that you are managing with Keptn. And this is one standard dashboard we have seen that organizations are interested in, because it gives, like, it's only 3 different metrics, but it gives a very good indication of the quality of a service that's up and running in your environments. So as an example here, we would have a service level indicator file. On the left-hand side, we have the name of the service level indicator. On the right-hand side, we would have the prompt UL, basically how to get this error rate. So you can just say it's a key value pair. And then in the service level objective file, you can reuse this. And the beauty here is that in the objective file, this is usually the file that defines a quality gate or a quality check, or you will use it in the quality check of an application or a microservice. You don't have to know which monitoring tool you're using or which data provider you're using. You can even exchange the monitoring tool under the hood, and you don't have to exchange this quality definition files. So that's pretty sleek, I would say. So in this case, we would define the error rate has to be smaller than 1. So we only allow a maximum of 1% of error rate. And we also count the number of database calls, and it has to stay within the boundaries of 2% increase to the previous runs. So there is a little bit more of meta information in the real objective service level objective file, like the number of runs you want to compare it to and the aggregation function. But it's the key points here are really to define criteria, a pass and a warning criteria. So if the pass criteria is not fulfilled, Keptn will also check for the warning criteria and then give you basically a total score. And you can also use this file for configuring Prometheus and Grafana in your monitoring tools or your data provider tools. So it's basically with the Keptn CLI, you would, this is sending a cloud event to Keptn. As I said, everything in Keptn is an event. So also the CLI is just sending events to the Keptn control plane. Like Keptn configure monitoring Prometheus would send this cloud event. Keptn will distribute it to Grafana and Prometheus or all those tools that are interested and actually subscribing to configuration events for a monitoring tool. These services, they will then execute the specific part. And for example, it will generate a Grafana dashboard and the alerts in Prometheus Alert Manager. And with this concept, you can make sure that the Grafana dashboards, they are like in sync with the alerts or in sync with the recording rules or with the scrape jobs. So with this concept, because you're feeding the same information to the generators or to the Keptn services, and they are then executing this. Sorry. So in this sense, they cannot drift out of sync. You can only drift out of sync if you touch them manually and if you manually reconfigure them. But you can always do a Keptn configure monitoring again to keep them in sync. So this is one part of how we can use these files, but there is a second part how we can reuse these files. And this is where we call it the Keptn quality gate. So it's on the left-hand side, it's basically exactly the same information. On the right-hand side, we now use Keptn to evaluate the quality of our microservices. So for example, we start an evaluation for the last 30 minutes. So basically Keptn will fetch, let's say, quality data or the metrics from Prometheus or Neoload or any other tool. Will fetch a metric for the last 30 minutes for a particular microservice with the information of this SLI file and the SLO file. Basically, those two files you don't use them in the CLI command because they're already stored in the Git repository. But just to make the point here, I added them to this CLI command. But actually, they are stored in the Git repository, and since we already know which service we want to test, Keptn will find them, apply them. In the sense that it will reach out to the SLI providers, so basically the data providers like Dynatrace, Prometheus, or whatever other tool you have connected to Keptn, will reach out to them, evaluate the data, like the error rate, evaluate it to the previous run, or in this case, it's not a percentage, but it's a absolute threshold. So if compare it, if the error rate that it got from Prometheus, if it's smaller than 1%, score it, and then apply a score between 0 and 1, and then come back with the total score. And depending on the total score that's defined in the objective file, will give you either a pass, like a thumbs up, or a thumbs down if the total score is satisfying when it comes to your service level objective file. And basically, you can do whatever you want with this. If you want to stop promoting this artifact into the next stage, like production or the pre-production phase, or if you just want to ignore the score. But actually, we should not ignore when we have this possibility to do this quality evaluation really, really easy, just based on those files. And remember, you can reuse the indicators file, and also for the response time, the error rate, and the throughput, Keptn is already providing those metrics out of the box. You don't even have to write this file. But you can write your own indicators, like the number of the database calls for a specific service, because that's very, very application specific. So in this sense, you can automate huge parts when it comes to onboarding new workloads to your Kubernetes environments, but also if you don't use Kubernetes, you can still make use of this concept of a Keptn quality gate, or you can configure other tools that are living in your ecosystem. So I will go quickly through these slides how to actually use Keptn. So when I was talking about Keptn and workflow, it's basically, we used to call it let's say a delivery pipeline, but in Keptn it's not a delivery pipeline with a lot of pipeline code, because you would only define what you want to have, like a stage. First stage is called stage, like staging, and prod is the second stage, and you would only define the deployment strategy and the testing strategy. And you don't have to find which tools you're using. That's defined in the Keptn's uniform. It's indicated here. So the uniform of the Keptn will basically show you what do you want to use for your configuration store. It's GitHub. What do you want to use for the deployment? It's Helm. You want to connect it to your ChatOps tools like Slack or Microsoft Teams. In this case, it's Slack. You want to connect to your testing tool, that's JMeter. You want to connect it to your automation tools like Keptn or ServiceNow. And you also want to connect it to an observability provider. And in this case, it's Prometheus. So that's what you define in a file called the Keptn's uniform. In the shipyard, you just define what is the environment Keptn should work upon. So Keptn will set up the Git repository, will set up the environments and set up the namespaces in the Kubernetes cluster. Next thing is to onboard services to Keptn. You apply some Helm charts to Keptn, or not, you're not applying the Helm charts to Keptn, but basically you're providing the Helm charts to Keptn so Keptn can use them in its internal Git repository to version control them and to make sure they always, like it's the version that is stored in Keptn is also the version that is applied in your Kubernetes cluster. Keptn can then configure the monitoring provider based on SLI and SLO files. So you will also add SLI and SLO files that I've shown you before to the Git repository. And with this, Keptn will then create and generate the scrape jobs, all this configuration, also for Grafana. And finally, you will deploy an artifact, or you can deploy an artifact. And with artifact, I basically mean a new microservice, a new version of a microservice, by just referring to the new image that you want to deploy. And Keptn will start its internal workflow, will update the Git repository, will update the, here we go, will update the stage, and will update your Kubernetes cluster by deploying the blue or the green version of the microservice, will trigger the tests, like triggering the JMeter tests, will score the tests. So again, once the JMeter tests are finished, the JMeter integration of Keptn then will send out the event to Keptn. The JMeter tests have just finished. Keptn also knows when they were started, so Keptn can reach out to the data provider and will find the data for exactly this time frame. We'll score it and then can decide if it's promoted or not. In this case, if we want to promote it, we can go on with the very same workflow in the next stage, which is production in this case. We can also skip some parts of the workflow. So if we don't have any tests, let's say for production, we won't do a load test anymore, because we usually have our end users hitting our environments with some load, so we don't need to execute an additional load test. But still, we want to score it after a couple of minutes if the actual new version that we deployed, if it satisfies the criteria. And then we can again decide, or Keptn will give us a score, and we can decide if we want to keep it or want to roll it back. This can be also done automatically by Keptn. So in this case, you can do a lot of automation, not only for automating for automating the onboarding of new workloads to Prometheus, but also automating when it comes to rolling out new versions of your application, when it comes to integrating more tools, when it comes to automating operational aspects. Because as said, if there is a problem event coming in, Keptn can basically execute the same workflow, but it's first doing a rollback, then checking if the rollback was actually satisfying. So if there was an increase of an error rate, we roll it back. Keptn will check, is the increase of the error rate now decreasing, and if is it now passing again this quality gate, and then we'll keep this version, otherwise it will escalate, for example. So in this sense, we can integrate Keptn with a lot of different tools with this with the concept of cloud events. I just provided here a couple of tools that are living in the Keptn ecosystem, I would say. So we have our GitHub repository. Our usual repository is github.com/Keptn, but other services, they live either in keptn-contrib, which is for Keptn contribution, or in Keptn Sandbox. So first we start with Sandbox projects. Once we see more adoption of the Keptn community and we see high quality of the service, they are promoted to the keptn-contrib organization, let's say. And in this case, we have, for Prometheus, we have two services. One service is responsible for configuring Prometheus and receiving alerts from Prometheus and translating these alerts from Prometheus into a payload that also Keptn can understand. So it will make sure that all the events that are floating inside the different microservices of Keptn or inside the Keptn installation, they are all having the same format, all the same cloud format. So this is done by the Prometheus service. And then we have the Prometheus SLI service, which is basically retrieving or used to fetch the service level indicators from a Prometheus endpoint. And we already, as said, we already put in some metrics here. The response time, the error rate, the throughput, that's already baked in. And once Keptn knows what's the name of your service and where does it live, it can automatically create this for you. And based on this, we also now have a Keptn Grafana service that it's not yet in our keptn-contrib repository, but it's in our Sandbox repository, and it's listening basically to the same events and setting up a dashboard for you in Grafana based on those three metrics. And if you want to see more or different kinds of dashboards set up, just remember it's an open source project. So if you're interested in it, please go ahead and check it out. You can also open up some issues, or even better, if you're contributing with a pull request, if you want to make this project like bigger, want to be part of the Keptn community. Yeah, I'm almost at the end of my talk. I just want to point out, to highlight some of the resources that I found during my research, and also found when working with customers. So here are a couple of those tools that are used to generate Prometheus configurations, or GitHub, but Grafana configurations. So you will find a couple of them. If you have more, let us know. I will share the link to the slide deck just in a minute, so you can also comment on it. I have linked also a presentation here on the REP method. In the slides is also a link to the presentation of SLIs, SLOs, and SLAs from Google. That's very, very nice. And yeah, if you think Keptn is something, some tool that might be interesting for you, check it out. It's keptn.sh. That's our website. As said, all the source code lives on GitHub, so you can also go there, download it. It's basically one CLI that you download, and from the CLI that's connected then to a Kubernetes cluster, and you can install it on a Kubernetes cluster. If you don't want to use it on the Kubernetes cluster, we also provide a new installation option where you're using Keptn on a small Linux box, and Keptn will come with its own, let's say, runtime, and the runtime is keys. I'm not sure if you've heard of it, but keys is basically K3S. So it's a single binary Kubernetes cluster where you can run the Keptn control plane, and you can still connect all the other tools to the Keptn control plane, but you don't have to install it in your running Kubernetes cluster. Yeah, so I just provided a couple of links here, and I think that's it. So thanks a lot. If you have any questions, I think we got some time right now. Otherwise, we will do the break, but I think Joseph will decide what we are doing next.
Yeah, thank you. Thank you for your talk. And yeah, guys, any questions? Chat shows no questions.
So just put in the slides if someone is interested. That should work, I think.